8.5, we've got factoring x squared plus bx plus c. This is what we consider to be the easy form of factoring. So in order to factor this, let's look at question 1, g squared minus 5g minus 14. We're looking for the factors of 14, or negative 14 in this case, that add up to be negative 5. Well, these factors are going to be negative 7, positive 2. Because there's no leading coefficient in front of our g squared, we just break it apart. We've got g minus 7 and g plus 2. Question 2, same idea. R squared plus 6r minus 40. We're looking for the factors of negative 40 that add up to be a positive 6. Well, that's going to be 10 and negative 4. So we're going to get r plus 10 and r minus 4. And then last, we've got d squared minus 18d plus 45. We're looking for the factors of 45 that add up to be negative 18. Well, I know that's going to be negative 15 and negative 3. So I get d minus 15 and d minus 3. And so if you want to try to remember this, remember you're looking for the factors of c that add up to be b. Here we're looking to factor ax squared plus bx plus c. And so we use this when we have a leading coefficient greater than 1. And to help us remember how to do this, this is going to be our slide, divide, bottoms up factoring. So let's look at question 1. 5x squared minus x minus 18. We're going to slide the 5x back. So 5 times 18 is 90. So we've got x squared minus x minus 90. We're looking for the factors of negative 90 that add up to be negative 1. Well, that's negative 10 and 9. So we break it apart. We've got x minus 10 and x plus 9. We'll then divide by our leading coefficient, which is 5. If it divides evenly, go ahead and divide it. So in this case, we get x minus 2. If it doesn't divide, you bring it back out in front, or bottoms up in this case, and you've got 5x plus 9. And this is your answer. Question 2 is the same. You've got 10b squared plus 11b minus 8. We're going to slide the leading coefficient back. We've got b squared plus 11b minus 80. Factors of 80 that add up to be 11. Well, I know that's going to be, 16 and negative 5. So we're going to go ahead and plug this in. We've got b plus 16 and b minus 5. We want to divide by our leading coefficient, which is 10. In both cases, this doesn't work, so we have to simplify our fractions. So instead of 16 over 10, I end up with 8 over 5. And instead of 5 over 10, I end up with 1 over 2, or 1/2. And in both cases, I need to bring the denominator back out front, or bottoms up in this case. And I get 5b plus 8 times 2b minus 1. And that is our answer. Questions 3 and 4, same idea. We're going to take our leading coefficient, in this case 6, and we're going to slide it back. And then we're multiplying. So this becomes k squared minus 10k plus 24. Factors of 24 that give you negative 10. Well, that's going to be negative 6 and negative 4. So I've got k minus 6 and k minus 4. I want to divide by my leading coefficient of 6. And so if it works, divide. 6 divided by 6 is 1, so I've got k minus 1. And in the other case, bring the denominator back out front. So 6k minus 4. And this is our answer. We'll do the same thing in 4. We're going to take the leading coefficient and slide it back through multiplication. X squared plus 10x minus 24. We have a negative 24 and a positive 10, so that's going to be 12 and negative 2. So we separate this. We get x plus 12, x minus 2. We're going to divide by our leading coefficient of 3. If it divides evenly, go ahead and divide. So you've got x plus 4. If it doesn't divide evenly, you bring the denominator back out in front through the bottoms up, and you end up with 3x minus 2. And this is our answer. So this ends up being the same procedures as the previous examples, except in this case, sometimes you have to factor out a GCF first. So in question 1, let's see what they all have in common. We've got 8, 32, and 14. Well, I know right off the bat that all of these have a 2 in common, or a 2 can be factored out from each term. So I'll factor a 2 from each. And when I do that, I've got 4y squared minus 16y plus 7. Now I'm going to go through the process of slide, divide, factoring. I slide the 4 to the back to the 7, and I get y squared minus 16y plus 21, or 28, sorry. And now I'm looking for the factors of 28 that give me negative 16. Well, that's going to be negative 14 and 2, or negative 14 and negative 2. So y minus 14, y minus 2. I'll divide by my leading coefficient of 4. And in both cases, it doesn't go evenly, so I have to reduce the fractions. So instead of 14 over 4, this will become 7 over 2. Instead of 2 over 4, this becomes 1 over 2. And in both cases, I'll bring the leading coefficient back out in front. And I've got 2y minus 7 and 2y minus 1. Do not forget to bring down your GCF from the beginning. And so this is our final answer. Question 2, you've got 4p squared minus 8p plus 60. I should notice right off the bat that all of the terms have a 4 in common, so I can factor out a 4 from each term. So I'm left with p squared minus 2p plus 15. So now I'm just going to factor what's left over. Well, the factors of 15 that add up to be negative 2 are negative 5 and positive 3. So I've got p minus 5 and p plus 3. I don't have to do any slide divide here because I didn't have a coefficient, so the last thing I need to do is drop down my original GCF, and this is my answer. In the last part here, we've got special cases, or in this case, special products. Notice that in all the examples, we are missing the bx term. So either you remember the shortcut, or you're going to have to do these the long way doing slide divide, bottoms up factoring. And in order to use slide divide, you've got to remember that you can add a 0x or a 0 variable in the middle. So we're going to add in the 0 variable to question 1. We've got 9z squared plus 0z minus 16. Now we're just going to use slide divide factoring. So we're going to take the leading coefficient and we're going to slide it back. In this case, we get z squared plus 0z minus 144. Factors of negative 144 that give us 0, well, that's going to be negative 12 and positive 12. In this case, we'll try to divide by our leading coefficient, which was 9. If it doesn't work, in either case, you reduce your fractions. So instead of 12 over 9, we're going to be looking at 4 over 3 and 4 over 3. Both cases, slide your denominator back out front, and you're left with your final answer of 3z minus 4 and 3z plus 4. Question 2, same idea. We'll use slide divide here. We're going to add in a 0b in the middle. And then we're going to slide the leading coefficient back. So we slide it back through multiplication. We've got b squared plus 0b minus 144 again. In this case, factors 144 that give you 0, well, we know this. It's 12 and negative 12. So we've got b minus 12 and b plus 12. We'll divide by our leading coefficient, which in this case was a 4. In both cases, this works. And we've got b minus 3 and b minus 3. But here's the catch. We should notice something in the very beginning of this problem. When we reduce this, this doesn't make up what we got. B minus 3 and then b plus 3, sorry, don't give us 4b squared minus 36. So if we go back to the beginning of this problem, we should have noticed we should have been able to factor out a 4. And we should have just started the problem with b squared minus 9. So to fix our answer, we'll put the GCF of 4 here, and we've got b minus 3 and b plus 3. So this is our actual answer. We missed the GCF in the beginning, and the slide divide bottoms up factoring took care of it for us, but we need to include it in our answer to get full credit. All right, let's look at question 3. Same idea here, or maybe in this case we just use the shortcut. Remember, for special cases and special products, these are perfect squares. And I know that the two binomials have opposite signs but the exact same coefficients. So in this case, if I'm dealing with 4x squared minus 9, really all I need to do is take the square root of the first term, so the square root of 4 is 2, and the square root of the last term, which is 9, or the square root of 9 is 3. I'll put my x here, and I put a sign, and then I repeat the same thing with a different sign. And so this is my answer, 2x plus 3 times 2x minus 3. And so that's the shortcut, and it only works for special products. If we're not certain if this is really the answer, we could do it the long way, where we've got 4x squared minus, or plus 0x minus 9. We'll use slide divide. So we've got x squared plus 0x minus 36. Well, that'll be 6 and negative 6. So x minus 6, x plus 6. We'll divide by our leading coefficient of 4. Doesn't work, so we have to reduce our fractions, which in this case is 3 over 2. So our final answer becomes 2x minus 3 and 2x plus 3. So we got the same answer the long way that we got from the shortcut. If you can't remember the shortcut, make sure you use a method that you can remember, like slide divide, bottoms up factoring.